Okay, then start with today's topic, which is patch management, how to roll out and track security fixes on your systems. We'll have a very short view into the processes defined in the NIST special publications, and we'll concentrate a bit more on the onboard tools you will use with Linux and Windows, and we'll have some special tools which are perhaps geared more towards the students and home users, which are not managed by some central organization. So first of all, a little definition. What's a patch anyway? So this special publication 840 says it's an additional piece of code developed to address problems, commonly called bugs, in software. So it doesn't really mean to be security related bugs, but it could be any form of bug in a software. This goes by variants and other names like hotfixes, point releases, service packs, etc. Some will include multiple patches like a service pack. Some will just be a single patch. Some may be final, some may be just unofficial, meaning they are not coming from the vendor itself, but maybe from somebody else, or it's not yet quality tested. But for the purpose of this webinar, let's assume they are all the same. So what's patch management then? Patch management, as per NIST 840, is the process for identifying, acquiring, installing, and verifying patches. And when we look at the ISO standard 3111, which means vulnerability handling within our organization, then we would be here at the box that says develop and deploy remediations. And what we are talking today is about mostly the deployment part. So let's start with the first task, identification. What do we have to identify? First, of course, the systems that have software running that needs to be patched. This can be done from our inventory or asset management, or we could run a network scan for this. Most solutions you see about network patch management have some point about this here, or are mostly focused on network scanning. Some others say we can do this without any scanning. We'll use a passive discovery technique, which just means they are listening for the network traffic and look for IP addresses and hope to get some information from here, what applications or what type of operating system is sending these packets. Think of passive fingerprinting to get the idea behind this. So then after we've got the systems, we need to look into them to see what software is running there and which of it has vulnerabilities or misconfigurations. This is mostly done through the installation database on our system. But if we don't have one or we don't trust it, we may look into the process list or in the file system and see what we can find there. But this is less common than just querying the installation database. So we have systems, software. Now we need to look for the vulnerabilities that have security impacts. Of course, we have the vulnerability databases and the security advisories I've talked about in the last webinar. And last not least, we need the patches or other remediations that are available for the vulnerabilities. They will come mostly either from the security advisory or directly through the update channel from the vendors, which will mostly happen automatically if you've turned on automatic updates. So when we look into this, like looking what version of an OS or what OS are we running here on Linux, this is now somewhat made easy by the file etc OS release, which has a pretty name and a CPE name, which we can use to correlate vulnerabilities that have CPEs attached to them. Unfortunately, this CPE name may not always be present, like, for example, on this Kali Linux version. But most of the traditional distributions that have point releases are supplying a CPE name. And if you prefer something more human readable, you can use the pretty name. And the installed software on Linux, this is mostly done on the great Linux distributions like Red Hat or SUSE, Fedora, CentOS. They have the RPM package management system. So we have a lot of Berkeley DB files in varlib RPM lying around, and you can query them either with RPM or some other tool that can read Berkeley DB files. And for the Debian-based systems, the basic tool is called DPKG, Debian Packages. This is the tool that underlies practically everything else that is used for package managing on Debian systems. It's also called by apt and other systems. So querying this database is just as easy as a one-liner in a command shell RPM -QA or DPG -L. So gets a little more troublesome if we look for pending patches and updates, because we have to use a more advanced tool like here. OpenSUSE uses Zypper, Red Hat and its derivatives use Yum, and Debian systems mostly use apt. If you are into CLI tools, there's a couple of graphical tools also, but let's stay with these here. Here's an example of this, and as you can see, it lists you all patches and updates that are available, and you might have to somehow tune in on the security update. And at least Yum and Zypper allow you to include some flag that shows you the issue or CVE number. So we can here see that this has a Bugzilla IDs or CVE IDs attached. Although it's mostly here the same patch that is coming around for ng-HTTP. On Windows, it is not so much more difficult. The Windows version is kept in the registry, mostly at HK local machine software, Microsoft Windows NT current version. Don't confuse this with Windows. You won't find the version number here. You need to go to the Windows NT key. And there you can see it has several different keys that might be of interest. Product name is probably the one you might be looking at first. Here it says Windows 10 Home. It has a release ID 2009 here, or the display version, which tells you a bit more about the service pack that is included here, or the rolling update. In this case, 20H2. So I'm at the point of autumn last year. We can also, of course, query these registry setting with a rec tool, or if we are more into PowerShell, we might look into the Windows management instrumentation and use the Win32 operating system class or the get computer info commandlet. And if we want to look into the installed software, we get two graphical interfaces that interface to the Windows update system. On Windows 10, we can look into setting, apps and features. This is the dark screen over here. Or in the older versions of Windows, we can, and Windows 10 too, we can look at system, programs and features and get these software lists. Or again, we could use the PowerShell and use get WMI object, Win32 product, and get a nice big list or table of the software that is installed on our system. So this is probably the best way to do this if we want to roll up our own system for that. So then we come to the point where we want to get the patches to our system. So the first part is, where do we get these from? The sources. Today, most vendors will do this not through media that they send out via mail to you, but they have an online update server where you can get this directly, sometimes mirrored to different countries so that you can get some server that has a decent network connection to you and is close to you enough. But yeah, the good points are here that you can get the stuff directly from the source and without delay, and don't have to worry about maintaining your own local infrastructure. But of course, it would mean that you have a working internet connection and a quite big pipe if you want to do this enterprise-wide. Remember, you may have some 10,000 PCs or so doing the updates, and this can be quite a bit of burden on your internet link. So then you can, or usually want, your own local update servers if you maintain a larger infrastructure, which means we have less traffic on the uplink. We don't need to download the patches from the vendor servers once to our own update server. And we could also use this as a means to include our own patches or patches for our own software on this update server. And we don't have to worry so much that the internet might break down, as long as, of course, the patches from the vendor have been downloaded successfully. And as a bit of privacy, nobody can actually see what's being deployed on my network. On the other hand, we have to maintain that server, and this is a bit of work, and it's a bit of hardware or software we have to deploy. And yeah, but I think if you're running a bigger infrastructure, you will find this worthy. As I've said, you will likely not deploy patch media like USB sticks, DVDs or something anymore, because this is too burdensome. And in most cases, I don't think you have air-gapped systems. But, and there's a catch, think of the major breakdowns after ransomware incidents we had in the past, when most systems get disconnected from the network, and then you will have to reinstall them manually or build up some quarantine network. So you may consider having some backups or patch media as some method of last resort. Of course, then you have to also deal with the problem of slipstreaming the latest patches to the installation media, which is another process. But I'm not talking about this here because that's a bit longer than we could cover in this webinar. And for the tools, this is quite easy. If you're running a larger Microsoft installation, you will have some kind of system management server with the inventory tool and the configuration manager running on it. Or if you're a small installation, you may have only the Windows Server update services. For Linux, this breaks mostly down to the process of mirroring the vendor repositories. Unfortunately, each distribution does it by its own means. And the days of mirroring FTP servers are long gone. So today we have to mirror HTTP servers. And every distribution has its own tool for this. RepoSync for Red Hat, apt-mirror for Debian, rsync is a pretty standard tool which is in use with SUSE Linux. And you have to run your own HTTP server, like Apache, Nginx, or whatever you like. There are some vendor tools like Red Hat Satellite you can use for this, but this is very vendor specific, so I'm not going to cover this here. And after you've done that for Microsoft and as well for any other operating system, you have to configure your local systems, of course. to use your local update service instead of the vendor ones. Then we are at installing the patches. So that's typically not a big deal. You just run your standard update commando like zipper up or apt-get updates. And it may get more complicated if you have to compile and package software patches for your own software. So you may then have to roll out some sort of continuous integration infrastructure or have something like a build server that is doing this work. And yes, that can be quite a bit of work. So you may have to think if your amount of software and patching is actually worth the effort here. Who does this? Well, again, quite simple. The system and network administrators responsible for the systems. And on the home systems or the self-administered systems, this is the end user. But what about systems nobody is responsible for anymore because that administrator is gone and that system is just running in some forgotten closet or corner of our offices, and nobody feels like taking up that work for it. And this is actually the some of the biggest dangers we may face when we consider vulnerabilities and how they happen in our networks. So one thing you should really be behind is getting all systems covered and finding the guy or the woman who's responsible for this system. And if there's a system nobody feels responsible for, or nobody is answering emails or the phone calls, see how you deal with that system and escalate here as early as possible, because this is usually the point where trouble is going to start. So, and then there may be side effects of the installation of the patches. There may be interrupts or downtime due to restarts or reboots. And this can get a bit tricky if we run hypervisors or container hosts and maybe do not have a cluster that can take over. And installing patches on clusters is another topic that can get tricky because yeah, you will have to perhaps break up the cluster during the period of the patching until everything is at the same software version. And then there's a point of what if something breaks during patch installation. We should be testing them before, but anyway, it may happen because well, there may be a power outage or the internet connection breaks down or the connection to the update server breaks down because somebody's doing a reboot or whatever. And it's not entirely clear what happens when something breaks during updates or when we later discover that this patch is broken and doesn't do what it is supposed to do. So best practice here that I would recommend is not only to do some sort of system restore point or making yourself familiar with the rollback procedures for patches, but the easiest way is just doing file system snapshots immediately before and after the patching, so you can safely roll back through this means. If you have a SUSE system, it's done automatically. Yum for Red Hat can do this. Of course, has to be configured. Windows Update can do this, but again, it has to be configured first. So snapshot tools are something I recommend is the Snapper tool, which comes with SUSE Linux, and that will require a snapshot capable file system like BTRFS or volume snapshots from the LVM, the logical volume manager from Linux, which means, of course, you have to run all your partitions in LVM partitions. So this is can be a bit of work to get your disk structure set up before. But if you have that, you have a nice way of doing timelines and pre-post installation patches, so you can look into this. And SUSE Linux is also quite happy with giving you a reboot option to an earlier snapshot. Windows can do the same thing with the volume shadow copy service, which requires an NTFS file system to take the snapshots. And again, volume shadow copies must be enabled first and configured properly, but they work quite well. The boot procedure to get into an earlier snapshot copy is a bit involved in Microsoft, which requires interrupting the boot on the Windows boot screen 2 or 3 times, if I remember correctly, before they show you the shadow copies. So, and then there is the way how the actual update is happening. So we may have different update mechanisms, like we have software that automatically updates itself. So that happens most of the time with our browsers. Think of Chrome or Firefox or Opera. Our mail clients like Thunderbird use the same infrastructure and same tooling here. So this could be completely done automatically, but requires some intervention if you want to do this with a local update server. We have the OS management tool that initiates the patching, which is the Windows Update Service on Windows. If you're running Linux desktop versions, you may have a tool called PackageKit, which is just another front end on top of RPM and Yum Zipper or apt, which can give you a more generic way to manage your updates from the user interface, and it has a graphical user interface too. Then we might have to direct our software to update itself, which usually happens because our software tells us, well, there's a new version around, would you like to update? And you can then push a button and it goes to the download server and usually just gets the new software version. Sometimes it's doing the complete update process by itself, like, for example, VideoLAN clients, LibreOffice, for example, which wants you to do the patching by yourself, which means clicking on the install package and closing the running LibreOffice instance before. Then we have a third-party management applications which initiate the patching. Think of all the enterprise patch management solutions that come around here: ManageEngine, Atera, SixSense. Opsi is a German company, which is, I think, the only company which really sells an open source systems. All the others are just free for minor installations or for some short period of time. Or we may have another tool that initiates patching. Think of network access control systems, which like to scan your system before it can connect to the network. Usually comes around with the IEEE 802.x standard. And they want something like this, or you have some health check technology here. And finally, of course, we can really go and install the patch or new version manually, just by downloading the patch or the diff applying patch and running something like make and make install again, which is also a valid way of updating a system. Also, it's more work than most of the others. And if you're a home user, it may get problematic to keep an eye on all the software you have on your systems. And quite a bit of this software is not managed directly by Windows Update or some other update manager. Think of Chocolatey, Homebrew, or whatever you may be running here. And there are some freeware tools that can take care of this. My recommendation used to be the Secunia Personal Software Inspector, but that tool has been discontinued. So the standard recommendations here are Patch My PC Home Updater, which has a freeware version. And the point I like about this software, it has a directly visible list of the supported third-party software, so I can have a look into this. When you start this tool, it just shows you in red all the versions that need some updates. Along the same lines goes Software Update Monitor Lite, which is a freeware version. It has a companion tool which also looks into driver updates. I think that's a neat idea. So you have to install two tools. The unfortunate way, but I think we have to go with this on freeware, that we get quite a bit of nagging here to buy the professional version, which is not too expensive. I give you that, but well, you have to see which one you like more, or which covers the software versions you have better. So there are a few challenges we may face when dealing with the installation of patches. First, there's the timing. So after the vulnerability has been published, exploits will happen sooner or later. So then is the part, when will the patch be released? Most vendors do try to keep the work on the administrator side low, so they will release patches only once a week or once a month. In rare cases, only once per quarter or biannually. So, and during that time, you may have a risk of exploitations, and there may be vendors who do emergency patches for vulnerabilities they think that are quite critical. So in the meantime, you may have to do something else, like use a workaround or a hotfix if you can get your vendor to give you some unofficial patch, or you may have to disable the service. This is actually something that has to be decided in a process where we have to go with this. Even then, the timing may, there may be some time still passing. Even if you have a patch, you may have a certified system which has to go through recertification after the patch. And that means you will have a quite lengthy process that will take perhaps several months to get the patches or the updated and recertified systems out to your customers. Then when we have a lot of work to do, we'll have to start prioritizing the work, and so it is with the patches. So we have to look into this, which patches we have to install when and where, which are the side effects and the time and resources we need for testing patches, which is usually so limited that we can afford testing patches only on the most critical systems. And when I have multiple update mechanisms, things like blacklisting a patch may become a challenge, because then I have to take care of all the different update mechanisms I've covered in a slide before. 3 slides before. Think of this. Here we have something 2, 4, 6 different ways of updating software. And there also may be the case that we will assume that some other tool, maybe administered by somebody else, might be already doing the update, and the end effect is that the update is completely missing. So we have to coordinate the different update mechanisms when we have multiple of them in use. So, and the last point already is verifying the patch. As I've said, the reason behind this is that things may break during patches. There may be power outages or network connection loss, or we have to roll back partly applied patches, or we really find out that something else breaks during the patch. And this happens rarely, but it does happen. The patch itself might be successfully applied, but it does not really fix the vulnerability. So if we see further exploitation, we might look again into this. Was the patch really successfully applied, or do we see a new kind of exploit, or did the patch not fix the vulnerability completely, or did we miss something else? And many patches, especially kernel ones or system libraries, require the system to reboot. So even if this patch is applied, we may have to reboot the system and see if it comes up successfully and does not fall back to an older kernel. And same with the services, we may want to verify that the service did restart successfully. The Zypper tool has some means to check for this from the command line. And then there are other side effects like how does performance go? Again, think of patches for hardware vulnerabilities that do have quite a performance impact on the CPU. We may look at increased memory consumption or increased disk space. Even this is something that may happen during a patch. Our disk may become full. So what does our patch process do when the hard disk is full? And so we might probably make clear that there's enough disk space before applying patches. There may be incompatibilities, like think of upgrades to cryptographic protocols like TLS. There may be configuration changes that have to be done on the client side or the server side when we patch the other end of the connection, or the patch itself might be broken. I have stated this already quite a few times. So as it happens, verifying the list of applied patches is not that easy and straightforward when we try to look into the system. So we have to do a bit more of command line work here. So think like list the installed patches with the Zypper or yum, and yum has the category of security installed. On Zypper, we need to be do a bit of grep. I think the least user-friendly here was Debian, when we had to look into the change log of all the packages on the system, which is quite slow. And we may also have a look into the installer history files, which are usually kept somewhere under /var/log. And if you would like to have an overview, you can use a commercial tool for Linux systems, or you can have a look into a tool called Packity. This was originally developed at CERN for managing large Linux clusters. So it scales quite well to a couple of 10,000 machines. And it's now being maintained by the fine folks at Chestnut. It's basically a Perl script on a client side, which has to be installed on every system you want to monitor, and has a Perl server backend which gives you an HTTP front, and you can look to verify if your patches have been applied. Then there is the way of verifying installed software, which is again done by the low-level tools. You may verify this software by comparing it what has been laid down in the package database. RPM-V does this trick on RPM-based systems, and you get something like the file type, configuration file, or some other thing you might want to ignore, the more general file. And it tells you like size have changed, or the modification time has changed, the MD5 sum has changed, and a couple of more different flags. Debian has included something similar with dpgg-v, but it can only compare the MD5 sums. But at least it tries to be a bit compatible in its output to RPM here. On Windows, it's not quite as detailed, but maybe a bit more comfortable. You can look at the update history of your Windows Update server locally, or you can, of course, use your SMS or Vesus server to monitor the updates. So we're coming to an end. Yeah, one thing you may carefully consider is testing your patches, as a broken patch can disrupt your operations quite severely, either if many systems are affected, like think of rolling this out to all of your clients and then finding out that they can't connect to your enterprise database anymore, or you have some vital system that gets taken down by a broken patch. And of course, yes, testing patches needs resources, but rolling back a broken patch needs personnel also, because somebody has then to do the emergency cleanups. So as I've said, testing all the patches first is something you will probably not be doing because you don't have the resources for this. And yeah, don't worry or don't feel bad about this. Nobody has. And but it also means that we need some sort of separate hardware for testing. We might have some sort of deployment infrastructure or testing infrastructure, but then it means we have to coordinate ourselves with the developers to get some time slot here for testing the regular patches. And of course, testing the patches by ourselves will take some time. We may have also developed some sort of testing procedure and go through these checklists, which is actually a bit of time consuming. So you might think of, yeah, anything between a day and a week you may need for testing a single patch. The week would be probably the point where you will just apply the patch and watch it in operation for some time and until you feel confident that it doesn't break anything vital. So the alternative is usually to test only for your vital systems and services, or, and this is usually done by the vendors themselves when they update you through the internet, you apply the patches in smaller batches, only for a small group of systems, and then look for things that go wrong. So you can at least stop the patch the broken patch before it gets being deployed to every system in your network. So, and yeah, I've given you quite a few of points you may have to consider here. And when you consider it, write it down, and then you have done the first step in developing a patch policy. And this is something you should really be doing for your organization. And if you're going for ISO certification or want to be GDPR compliant, you have to have some sort of patch management, and this will require at least a rudimentary patch policy. But yes, this takes time and effort. I know this, and you have to develop so many policies already. But the good points is that issues that will come up get on the table and are hopefully resolved. You will get some buy-in from your management, and nobody should be fired for adhering to agreed upon policies. And I think at least here in Europe, it's at least very difficult to get fired when you did something that your management has agreed upon. You can also use this patch policy to manage expectations either by the management and or your end users. And you have everybody who is named in the policy who knows what to do. And as I've said, write down what you're doing already in the area of patches. You have a starting point for discussion here. And when you've done writing down what you're doing, you could also write down what you'd like to improve. So you've, in an easy way, done the first 1 or 2 steps in developing your patch policy. But yes, it's the first 2 easy steps. The next steps get more difficult because more people come in. This takes me to the end of today's webinar. So, and let's sum up what we've done here today. Patching may look easy. Well, we just turn on auto updates and that's it. But when we do this organization-wide, it becomes challenging. We have to keep track of open vulnerabilities, of already applied patches, how to deal with all the different kinds of systems of management, of patch systems, and how to avoid that a patch can affect the stabilities of our systems or services. So, and before I take questions, let me just thank you for your attention, and please fill out the feedback forms so that we can see what you have upon your chest for the next upcoming webinars, which go about a bit more about scanning for vulnerabilities. Here's a couple of references, and let's see what's here on patches. So I'm going to look at them in the chat, so there's nobody here. And so you might as well unmute your microphone and ask your questions directly. So, and okay, seems that there are no questions. As usual, we'll put a PDF of these slides next to the recording on the GLAD website. And yeah, I think we're done for today. And let me thank you all, and especially Pauline, for hosting and recording the session. And hope to see you back on the next upcoming webinar, which will be on the 28th of June. Thank you for listening.
Thank you. Thank you, Klaus. Bye.